Hello all, we are going to see different distance metrics used in machine learning algorithms in this video. So what is distance metrics? Where do we use this distance metrics? Let us try to understand with the help of the simple diagram given here. So normally this distance metrics used to assess how two data points or observations we collected to build the model are similar. For example, in classification algorithm or in clustering algorithm, we assess the similarity of the two observations. Based on that, we will group them in one cluster or in a particular class. To find how much similar, we use the distance metrics. Then we have n number of distance metrics, many number of different metrics. So why do we have different distance metrics and how to choose a particular distance metrics? It depends upon the application we have chosen. For example, let us look at the picture given here. I wanted to travel from Times Square to Rockefeller Center, right? So to find the distance between these two places, either two different colored lines are given here. One is in the red line, the other one is in the blue line. So the red line says the direct path, I mean the diagonal path to travel from Times Square to Rockefeller is given, right? But anyhow, we cannot take this direction since it is since for air travel it may be possible, but for normal travel this distance is not, this direction is not possible. However, if that blue line indicates that the path, I mean the footpath or travel path exists between this two area. So normally to measure the distance between these two points, we will be calculating the distance using the blue line, not using the red line. However, suppose if you want to find the air travel distance, you can use this red line. So this again, choosing a particular matrix is depends upon what is the application you are working, right? I mean, to find the distance using the red line, we can apply Euclidean distance algorithm, whereas for the blue line, we will be applying Manhattan distance. So similarly, we have other distance metrics also. It depends upon the algorithm you are, I mean the algo application you are going to work, right? We are going to see different distance metrics used in the machine learning algorithm in this video. Any distance matrix has to satisfy the following properties. One, the first is symmetry. It means that the distance between P and Q must be similar to distance between Q and P. And it must be non-negative. It means that the distance must be greater than or is equal to 0. It should not be in negative value. And if it is equal to 0, means that P is equal to Q. This is called as identity property. The last one is triangle inequality. It means that the summation of two sides must be greater than the value of the other side. This is called as triangle inequality. That any distance matrix has to satisfy this triangle inequality also. So these are the properties any distance matrix has to satisfy. So here in this video, these are the important distance metrics which are often used in machine learning model. We are going to see it is Euclidean distance, Manhattan distance, Chebyshev distance, Minkowski distance and cosine similarity. Minkowski distance matrix is used to measure the distance between the data points in a multi-dimensional space. It is the distance is calculated using the given formula. We say that Minkowski is the special case since it is the generalization of Euclidean distance and Manhattan distance. In the given formula, if we replace p-value with 1, then it is the formula to calculate distance using Manhattan distance, where if p is equal to 2, then this Minkowski formula will give us Euclidean distance. When p is equal to infinite, then it is a Chebyshev distance. So hence we say that this is the special case. The next is Euclidean distance. This is the widely used distance matrix in the machine learning model. We can find the distance between any two vectors by applying in the given formula. This is called as L2 norm, where L2 norm stands for length of a vector in a normalized space. So for this, I mean the formula used in Euclidean distance is very much similar to the Pythagoras theorem. The next distance is Manhattan distance, also called as city block distance or taxi cab geometry. It is it's highly preferable for a high dimensional space. It is used to calculate the distance between any two given points in a grid-like path. So here in the given diagram, if you look at, if you wanted to calculate the distance between A and B, either you can choose the uh, distance which is marked using green line, or otherwise red line, which is smaller we have to choose. But these are the two different paths exist to uh, reach A, to reach B from A. The next is Chebyshev distance. This is also called as maximum metric because it measures the distance between any two points, the maximum difference over any of their axis values. For example, if we wanted to find the distance between x1, y1 and x2, y2 using Chebyshev distance, then we will be taking the maximum of y2 minus y1 or x2 minus x1. Right. Here in the given example, I wanted to find the distance between two points which are marked using red color. Right. I mean, y2 minus y1 is equal to 3 and x2 minus x1 is equal to 2. The maximum among this two is, I mean, this two values is 3. Hence, the distance between 2, 3 and 0, 0 by Chebyshev distance is 3. This is how we used to calculate the distance between any two points using Chebyshev distance. This distance matrix is normally used in warehouse logistics, where we can apply this to measure the time and overhead the crane takes to move a particular object. Cosine similarity. This is normally used in natural language processing to find the similarity between different documents. It measures the similarity in the direction of vectors and ignores the difference in their magnitude. That is the important point to be noted. It considers the direction, right? Um, Mainly it is used in vector search algorithms. The similarity of the two vectors is measured using the given formula. The given formula is cos theta is equal to a dot b, means it's a dot product between this two vectors a and b divided by the multiplication of their magnitude. So this similarity values will range from -1 to +1. The smaller angles between vector produces the larger cosine values, indicating greater cosine similarity. To make you understand better how to calculate cosine similarity, I have chosen a simple example. I have considered only two documents for simplicity. Document 1 says that the best data science course, and document 2 is data science is popular. I wanted to find similarity between these two documents. The first step is that you have to represent them using vector representation. For that, you have to choose the words appear in both the documents and put it to the tabular representation. Now enter how many times a particular value occur in each appears in each document. So this is the vector representation of the given documents. Afterwards, you have to find the dot product of the vectors. Here I have calculated the dot product between two documents, which is equal to 2, and then I am finding the magnitude of the vectors by applying it in the formula. I am getting magnitude of d1 is equal to 5 and d2 is equal to 4. Now we have all the values to apply in the cosine similarity formula. By applying the values, I am getting cosine similarity is equal to 0.447. Means that, here the cosine similarity value, if it is closer to 1, it means that they are greater similar. They are much more similar. Otherwise, they are less. Here the value 0.4 indicates that it is somewhat less similar. These are the some of the example application where we use cosine similarity, most popularly used in natural language processing and in some recommender system. Here in this entire video, we have seen very few distance metrics, but we have n number of distance metrics, but this distance metrics are widely used in machine learning model, hence I have chosen this distance metrics. Thank you for watching my video.